Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 9. And today we're looking at Section 9.2 on absolute value equations. There is only one objective in this section, and that is to solve absolute value equations. And the course SLO is to solve nonlinear equations. These equations are nonlinear. All right, so the first question I have for you is, what is an absolute value? Now, you might be thinking one of two things. If you're thinking, if the number is positive, leave it positive. If it's negative, make it positive. Well, that's okay. I mean, that's correct. But in this section and the next section, it's going to be much more helpful to remember that an absolute value is a distance. All right, so if we were a face-to-face class, I would play what I call the absolute value game with you, where every so often I would just ask the class, what is an absolute value? And you would all say a distance, okay? Specifically, the absolute value of x is the distance between x and 0 on the number line. So when you look at it that way, it starts to make sense. The other way I said it, if it's positive, leave it positive. If it's negative, make it positive. Because if x is a number like 3, well, then the absolute value of 3 is the distance between 0 and 3, which is 3. But if x is negative 3, the absolute value of negative 3 is the distance between negative 3 and 0, which is also 3. All right, distance cannot be negative. All right, now we're going to turn it around. This is a different question. All right, this is not asking about the absolute value of 4 exactly. In this section, we're talking about equations like the absolute value of x equals 4. So now that you understand that an absolute value is a distance, you know that means the distance between a mystery number x and 0 is 4. That distance is 4. So what is x? Think about that for a few seconds. The distance between a mystery number and 0 is 4. What is the mystery number? Well, it could be one of two things, couldn't it? It could be 4, but it could also be negative 4, right? So this equation has two solutions, all right? 4 and negative 4 are both solutions of this equation. Now, if it said the absolute value of x equals 0, what is x? Well, that's just a little different. It's saying the distance between a mystery number and 0 is 0. So in the previous question, we went, 4 units from 0 on either side. Well, if you try to go 0 units from 0, you're really not going to get anywhere. So in this case, this equation has only one solution, and that solution would be 0. And the last question I have to ask you before we get into the rule and then some examples is, if the absolute value of x equals negative 2, what is x? So this is saying the distance between a mystery number and 0 is negative 2. Well, what did we just say about distance a few moments ago? Distance cannot be negative. So if they try to sneak one of these past you, this equation has no solution. No solution. Okay. All right. So here's the rule for solving absolute value equations of the form absolute value of an expression equals 0. Notice the capital X. Sometimes I use that to represent an expression like 2x plus 3 or something. If a is a positive number, all right, and that's very important. If a is a positive number, then the absolute value of x equals a is equivalent to, we could call this a compound equation, x equals a or x equals negative a, all right? So what you're going to do whenever that number on the right-hand side is positive is you're going to make this into two equations without the absolute value. The other very important thing I need to point out to you about this is that before you can apply this rule, the absolute value needs to be isolated. All right, so there can't be any other terms out here. Like it can't say 3 plus the absolute value of x. If it says 3 plus the absolute value of x, you have to start by getting rid of the 3. All right, and I have at least one example like that, which I will show you. And then remember, if a is 0, there's just one solution, just x equals 0. And if a is a negative number, you don't have to do anything. Once you have isolated the absolute value, if you see a negative number over here, you can just stop and say no solution. Okay. All right, so here are the examples that I will be going over with you. So let me switch over to the tablet. Starting with letter A, the absolute value of 6 plus 2n equals 4. So let me point out a couple of things here. The absolute value is isolated. There are no other terms outside the absolute value on that side. And A is positive. Okay, so that means nothing weird is going to happen. We're just going to apply the rule, which says that this equation is equivalent to 6 plus 2n equals 4, or 6 plus 2n equals negative 4. So we're going to solve those two equations separately, and then our absolute value equation is going to have two solutions. Okay, starting with this one over here, I'll subtract 6 from both sides. I assume that you are all experts by now at solving linear equations, so I will do this part kind of fast. One solution is n equals negative 1. The other solution is subtract 6 from both sides, get 2n equals negative 10, divide both sides by 2. The other solution is negative 5. So the two solutions of this equation are negative 1 and negative 5. Okay, pretty simple, right? Next example, the absolute value of n over 3 plus 2 is equal to 4. So once again, our absolute value is isolated, and the number a, which is 4, is greater than 0. So this would be a perfect one for you to pause the video, try it, and then come back and compare notes. So I will assume that you have done that. This absolute value equation is equivalent to n over 3 plus 2 equals 4, or n over 3 plus 2 equals negative 4. All right, so I will subtract 2 from both sides of this one. That gives me n over 3 equals 2. And then I will multiply both sides by 3. And that gives me n equals 6. So one solution is n equals 6. The other solution is n over 3 equals negative 6. Multiply both sides by 3, you get n equals negative 18. So this equation also has two solutions. Those two solutions are 6 and negative 18. All right, next example. All right, can you see what's different about this one? What's different about this one is that the absolute value is not isolated. So please don't go ahead and apply the rule. If you apply the rule too early, what often happens is you end up with one solution that's correct and one that's incorrect. Okay, so before we apply the rule, we have to add 6 to both sides, and that's going to give me absolute value 2x is equal to 10. At this point, the absolute value is isolated, and the number on the right-hand side is 10. So 10 is the important number to look at here, not 4. All right, so applying my rule, the only way absolute value 2x can equal 10 is if 2x is either 10 or negative 10. Of course, if 2x is 10, that means x is 5. If 2x is negative 10, that means x is negative 5. All right, so this equation has two solutions, 5 and negative 5. I think you'll find that most of the time these equations have two solutions, but not always. All right, what's different about this one? The absolute value of 3y plus 2 is equal to 0. Well, what's different about this one is that the number on the right side is not positive. It is 0. So this is one of those special cases. The only way the absolute value of 3y plus 2 can equal 0 is if 3y plus 2 equals 0. And if 3y plus 2 is 0, that means 3y is negative 2, which means y is negative 2/3. So this equation has one solution. Negative 2/3 is the only solution. All right, which brings us to our last example in this batch. The absolute value of 3z minus 2 add 6 is equal to 1. So I really love this example because you have to be paying attention. Notice that the absolute value is not isolated. Okay, so the fact that that 1 on the right side is positive has nothing to do with it. I don't care about looking at that number on the right side until my absolute value is isolated. So since the absolute value is not isolated, we are going to subtract 8 from both sides. Oh, look what happens. We end up with the absolute value of 3z minus 2 is equal to negative 7. All right. So at this point, we can put down our pencil. Well, as soon as I point out that now it is isolated, however, negative 7 is less than 0, which means no solution. This equation has no solution. Remember, no solution can also be written like this. Okay. All right, so that's going to do it for that batch. Let's go back to the presentation and talk about equations of the form absolute value of x equals absolute value of y. So absolute value on both sides. And I'm thinking that these expressions x and y will usually be variable expressions. So what can you say about two numbers that have the same absolute value? Suppose I tell you I'm thinking of two mystery numbers, and the only thing I tell you about those mystery numbers is they have the same absolute value. Could those mystery numbers both be 3? Yes, they could, right? Could one of the mystery numbers be 2 and the other one be negative 5? No, they could not, because 2 and negative 5 do not have the same absolute value. However, could one of the mystery numbers be 4 and the other one be negative 4? Yes, they could. So if the only thing that you know about your mystery numbers is that they have the same absolute value, then either those mystery numbers have to be the same or they have to be opposites. They have to be the same or they have to be opposites. So when you see an equation in this form, it's also going to break into two separate equations like you see here. Okay, so I have two examples of that, and then we will already be done with 9.2. So let's switch back to the tablet. Starting with letter A, which is the absolute value of 3 plus 6n is equal to the absolute value of 4n plus 11. All right, those expressions have the same absolute value, which means either they are equal or they are exactly the opposite. Now be very careful when you write down the equation that says they're opposites. The opposite of 4n plus 11 looks like this, doesn't it? So I have to start by putting parentheses around 4n plus 11. Eventually, I will knock down those parentheses and distribute the negative sign. Let's work on this first equation. I have n's on both sides, numbers on both sides. And again, you're experts at solving linear equations, so you know what to do. 3 plus 2n equals 11. Subtract 3 from both sides. That gives me 2n equals 8, which means n is 4. The other possibility is that 3 plus 6n is the opposite of 4n plus 11. So as I said, I'm going to start by distributing that negative sign. Let me drop a little fence here so I don't get my work all mixed together. 3 plus 6n equals negative 4n minus 11. So now I'm going to add 4n to both sides, which is going to give me 3 plus 10n equals negative 11. And then I'll subtract 3 from both sides, and that'll give me 10n equals negative 14. Dividing both sides by 10, you get n is negative 14 over 10, which is going to simplify down to negative 7/5, right? We always simplify our fractions. And for the last example in section 9.2, this would also be a good one for you to pause the video and try yourself. So once again, I will assume that you've done that. If the absolute value of 8 minus y is equal to the absolute value of y plus 2, the only way that can happen is if 8 minus y and y plus 2 are the same thing, or they are opposites. Don't forget to put parentheses around y plus 2. All right, so first equation, I think this time I'll put the y's on the right side. Why not? 8 equals 2y plus 2. Subtract 2 from both sides, I get 6 equals 2y, which means y is 3. For the other equation, I get 8 minus y equals negative y minus 2. And now something kind of weird happens. No matter whether you're trying to put the y's on the left side or the right side, at some point you're going to do plus y on both sides. This does not usually happen. The y drops out on both sides. So do you remember what the interpretation is when you end up with an equation that has no variables in it and instead says something like 8 equals negative 2? I remember back in the days of chapter 2 telling you about my high school math teacher who used to say, liar, liar, pants on fire. All right, so any value of y that makes 8 minus y into the opposite of y plus 2 will also make 8 equal negative 2. And since there are no y values that make 8 equal negative 2, there are also no y values that do this. So this second equation has no solution. However, the first equation does have a solution. So the only way that the absolute value of 8 minus y can equal the absolute value of y plus 2 is if y is 3. That's the only possibility. So those two expressions can be equal. They cannot be opposites. All right, and that's going to do it for section 9.2. We'll see you next time.